This is a demonstration of HD Explorer version 5.0. HD Explorer is a neurotargeting software made by Soterix Medical that can be run on any PC, whether it be a desktop or a laptop. The main additions in this release include the ability to model extracephalic, shoulder and neck electrodes, and data export capability for further post-processing. I will be talking about all of these exciting additions in this video. There are 3 steps to use this program. Let's begin. Step 1. Note that the interface has 3 sections: the control panel on the left, the help section on the right, and the displayed results in the middle. The help section and control panel can be minimized and the entire application resized as needed. Select the subject that you would like to explore for current flow. In the control panel, the desired head model can be selected from 3 different menus: adult head, standard head, and stroke patients. The base HD Explorer versions comes preloaded with 3 adult heads and 1 standard MNI 152 head. There are 2 electrode densities, 93 and 338, to choose from in the adult male 1 model. The higher density option can be used to simulate sponges, including the capability to model extracephalic and neck locations. Let's select adult male 3 and the 93 electrode density option. Once the head is selected, the different segmentation masks can be viewed in the anatomy viewer in the middle. The skin, bone, CSF, gray matter, and white matter of the head can be seen in 3D. You can zoom, pan, rotate using the keyboard and mouse. See the help section on the right for instructions. Selecting lock orientation will lock the viewing angle so that you can visualize the different masks at the same orientation. Selecting center view will reset the view to the original starting view. Step 2. In the second step, you design your own electrode montage. 2 different layouts are available by which electrodes, their individual current, magnitude, and polarity can be selected. In the drop-down menu in the Layout tab, there are 2 options. The flexible layout allows you to manually select your desired electrode and assign its current and polarity. The option Uniform assigns the same current to a group of electrodes. For example, let's create a typical 4x1 HD montage. This can be done using both flexible and uniform layouts. Let's begin with flexible. We'll be using a total of 5 electrodes with 1 center electrode surrounded by 4 returns. First, select the location of the center electrode in the 2D electrode layout. In this case, we'll select CZ. Now enter the current for the center electrode at its location. I'm going to enter 2 milliamps. To the right of the 2D electrode layout, the 3D electrode layout can be seen. The electrode that is selected will turn from green to red in the 3D view. Now select the first of the 4 outer electrodes forming a ring. I will start with FC1 and I will enter negative 0.5 milliamps as the current. Notice that with each electrode selection, the 3D electrode layout changes, showing you the selected electrode in red and the underlying cortical anatomy. The 2D and 3D electrode layouts can be resized by simply dragging the white line divider separating the 2, left or right. Let's select FC2 and CP1 and enter negative 0.5 milliamps through each of them. Now select the 4th and final outer electrode. Let's choose CP2. You will also notice that HD Explorer automatically enters the amount of current with correct polarity in its final return electrode. This is because the total current in has to equal the total current out due to current conservation. Now let's try a uniform layout. First, let's select the total amount of current we will use. In this case, we will again use 2 milliamps. We will use 1 center anode and 4 surrounding cathodes as before. With the default arbitrary selection method, click on the anode button and select where you want the anode on the scalp. We will use CZ as the anode. Now click on the cathode and select the 4 cathodes you want to use. In this case, we will use FC1, FC2, CP2, and CP1. Notice that under the uniform setting, HD Explorer will automatically set the amount of current at the cathodes. If you want to save your montage, you can simply go to File, Save. Later on, when you open the program back up, simply go to File, Load, and load that montage back up. If at any point you would like to make the main window bigger, the control panel can be minimized using the button on the top right of the control panel section. To maximize the control panel to its original size, just click the button again. If at any point you need assistance on what to do, click the Help section on the top right of the screen and the section will expand, providing instructions. Step 3. Explore current flow. Just press Explore current flow in the head. HD Explorer will now allow visualizing current flow through the entire head in both 2D and 3D. The default view is 2D. Here you can select to view the electric field, the current direction vector, and the subject MRI individually or all together. You can navigate through the head by simply clicking around in the 3D space or moving slice by slice at a 1 mm resolution by using the sliders in the control panel. The selected field intensity value in the control panel shows the field intensity inside the open white circle. This can be used to determine the field at any voxel in the head. The corresponding M&I location of the voxel is displayed right underneath it. The field intensity scale can be adjusted as needed using the buttons at the top and bottom of the bar to better depict current flow patterns. To explore the current flow in 3D, just click the 3D option in the control panel. The model can be rendered either as a solid surface or a transparent surface. The solid surface is the default view. You can zoom, change view, move, and rotate the 3D view as before using your mouse and keyboard. By clicking Display Cutting Plane, a plane will be shown in the rendering. The X and Y angles, as well as the distance from the center of this plane, can be adjusted using the scales to define a precise location. To cut the 3D volume at the plane and explore current flow inside the head, simply click Cut, and the head will be cut at that location. If you want to undo the cut, just click Undo Cut. By selecting Instant Cut, the plane will cut the head volume in real time as you adjust the cutting plane. The field intensity scale can also be adjusted here in the same way as the 2D view. Now let's talk about one of the main additions in this release, data export for further post-processing. Clicking on the Line Export option will present you the option for setting the start and end coordinates either manually or by direct clicking on the 3D surface plot. For direct clicking option, first click on the green crosshair next to the start point. Notice when you do that, the cursor changes to a plus crosshair. Now click anywhere on the 3D surface to register the start point. Likewise, do the same for the endpoint by clicking on the red crosshair. In the manual option, you enter the coordinate values. Clicking on Cut by Line will cut the 3D volume at the line location. The cut can be undone. The electric field values induced along this line can now be exported to a .csv file by clicking on the Export button. The file will include the x, y, and z coordinates of interpolated locations along the chosen line and the corresponding induced electric field values. Likewise, clicking on the Sphere Export option will present the option for setting the center of a sphere either manually or by direct clicking on the 3D surface plot. For the direct clicking option, click on the green crosshair next to the center. Then, click anywhere on the 3D surface to register the center coordinate. In the manual option, you enter the coordinate value. Next, you enter the radius of the sphere. Clicking on Cut by Sphere will show you the 3D volume contained within the sphere. This cut can be undone. The electric field values induced within the sphere can now be exported to a .csv file by clicking on the Export button. Similar to the line export option, the file will include the x, y, and z coordinates of the interpolated locations within the chosen sphere and the corresponding induced electric field values. Let's go through one more example. Going back to step 1, let's select the adult male 1 but the 338 electrode density option. For step 2, let's select uniform. Then select the total current you want to use across all electrodes. In this case, let's choose 1.5 milliamps and choose pad configuration in the selection method. Click on the anode drop-down menu and select F3. Note how HD Explorer simulates a sponge pad at the F3 location by selecting 9 electrodes. Then select the cathode and select the RSH location. Note that HD Explorer has a dedicated sponge pad at the location. Note that the current is split evenly amongst the electrodes simulating the F3 electrode. As before, just click on the Explore Current Flow button to explore in 2D and 3D. You will see that what we have created is a F3 extracephalic montage using conventional TDCS. In this way, you can use HD Explorer to create any HD TDCS or conventional TDCS montage. HD Explorer, another innovation only from Soterix Medical. HD Explorer is optimized to work with Soterix Medical family of HD and single-channel stimulators. For more information, visit us at soterixmedical.com.